Hey guys, in this video we are going to discuss the Codeforces round 895 that was rated for Dev 3. Obviously it was not rated for me, but I tried the first 5 problems. The problem F and G were a bit tough for me, I guess. Even if I was able to do them, then I definitely wouldn't have been able to explain them to you well. So I didn't try those, but I'll try to explain these 5 problems in detail. So the very first problem is fairly simple. It says you have 2 vessels with water. The first vessel contains A grams of water and the second vessel contains B grams of water, and both the vessels are very large, blah blah blah. So like a bit of gibberish, you can skip this part. And then they say that you have an empty cup which can hold up to C. So probably this has the markings on it, and thereby you are able to measure that how many grams of water you're picking up using this particular cup. And now we can transfer the water from A to B, right, using this cup. Let's call this cup C as well, right? So we are gonna pour some water from A to B or B to A, and at the end of it we want to make both of them equal, so we have to print the minimum number of moves required to do the same. Now it's a very simple question. The only thing is that we firstly have to find out the difference that exists between these two glasses, right? And then for the difference we can just divide it by the amount that C can carry in a single go and take the upper bound for it or the seal value for it. That's pretty much all you need to do in this particular problem. So yeah, here's the implementation for the same. So you just say give me A, B, C, right? And the difference technically is just A minus B plus 1 divided by 2. Why I'm dividing by 2 over here? So the simple thing is, let's say one cup had 5 grams of water and the other had 10 grams. Grams kind of seems problematic over here. It should have been liters, but anyway, cool. So one cup has 5 grams of water, another has 10 grams of water in it. So technically you'll only be transferring 5 divided by 2, that is 2.5, because as soon as you'll transfer 2.5 grams of water from the cup having 10 grams, both of them eventually would have 7.5 grams in total. Cool. So difference has to be divided by 2. I'm taking a plus 1 over here so as to take the seal value. And after that, now I know that C is the cup I'm gonna use, right? So for that I have to take the seal value as well. So def plus C minus 1. The if people don't know what this does over here, so this is simply saying that I want to take this. Okay, let's just write it as seal of def divided by C, right? So that's exactly what it's doing. Plus C minus 1 is nothing, but it says that okay, just add plus C minus 1 to the numerator, so that whatever value is you get is actually the seal value and not the flow value. Cool. So that's pretty much it for problem A. Let's move to the next problem, that is problem B. Okay, so the problem B states that you are in a corridor and there are rooms in front of you. Now you can rush through a room, but as soon as you rush through a room, the trap gets activated after some seconds, right? So there would be two variables that will tell the same. So for example, over here they have given that D1 is equal to 2 and S1 is equal to 2. So that basically means as soon as you cross the gate 2 or the second gate or the second room, the trap would get activated after 2 seconds, right? So technically if you are entering the second room at first second, right, then after 2 seconds the total time, the current time would become 3, right? So at third second the trap would get activated, and once the trap gets activated you can't come back to it. So you have to tell that what is the maximum distance you can run from the start position till the end, right? Or basically when you run from left to right, you also have to come back. So in case you rush through a room and the traps get closed, then obviously you'll be trapped. So you don't want that kind of a situation. So you simply have to state that what's the maximum value you can run such that you can also come back. Or in other words, I can say that even if you are triggering any traps on the way, then you should be able to come back to your original position before that trap gets activated and you get stuck. Cool. So this was also simple. I could have actually done it far more simpler, but anyway, cool. So over here, just take the values. I'm taking a vector int. You can take a vector of pairs as you like, and the result would be minimum of result. So I want to check for all the pairs that are in it. So basically they are giving me two things. So the pairs they are giving me would have the location and the time taken for activation, right? Now the location is given in the very first value, or you can say the first field of the pair, and the time taken for activation is given in the second field of the pair. So my result would be the minimum of the current location where it is at. For example, if you remember, we were saying that for the door, for the trap that is placed at the door 1, we would have already covered some distance so as to come to that particular door or come to that particular room, right? So let's say it is the room X, right? So in order to come to that, we would have already traversed X minus 1 units. Or you can say, for example, in the example they had given, it was the second room. So in order to come to the second room, we have to pass 1 and 2. So automatically 1 second had passed by then. Or you can say X minus 1 seconds would have passed. Now plus there would be some time required, right, for the activation of it. For example, if I say that, okay, 3 seconds are required for its activation, then what you'll say is that 3 seconds is the round trip time I'm getting. So let me just illustrate this on the iPad itself. Okay, cool. So if you're over here, right, and let's say this is time equal to t. Let's just use a variable t. Now it says that, okay, after s seconds, the trap would get activated. So that basically means you have s seconds to complete this particular round trip. Now if you have s seconds to do so, you can say s plus 1 divided by 2. Why I'm adding 1 over here? Now that's the different part, because I'm firstly dividing by 2. That is because once you start rushing, right? So once you start rushing, right, you have to also come back. So that basically means there are 2 parts of this trajectory you're going to follow. That's why I'm dividing by 2, because you have to cover double the distance. But for the last one, you won't be spending time going forward, right? And that's why I'm adding a 1 over here. So as to include this thing that for the last block, I'm not going to go towards its right. I hope this particular point is clear. And I'm saying that this is the value that should, that I need to take the minimum amongst all the values. So I'm saying my res is equal to minimum of whatever the result I am having right now, comma, this particular value for this particular pair. And at the end, just spit out the result, and that would be correct. Cool. Let's move to the next problem. That is, okay, let's just go to the next problem. Let me just open all the problems, C, D, E. Yeah, that would save time. Okay, so the problem states that you are given 2 integers L and R, and you need to find positive integers A and B such that the following conditions are simultaneously satisfied. So your A plus B should lie between L and R, and a GCD of AB should not be equal to 1. Now, at the first glance, firstly, it seems like a simple problem. Then you start doing it, it kind of seems hard. And it's one of those problems wherein you can go with a lot of if-else statements. But at the end of the day, you have to understand what's the actual logic behind it or how to solve it easily. So let's try to understand in a very layman's term. So what if I say you that there are two that you have to form a product, you have to form a sum S, right? And it should comprise of 2 numbers that are both even, right? So that basically means that S should also be even. If S is even, then only both of the numbers that are comprising of it are also even, right? So if my sum mod 2 is equal to 0, right? Then let's say A plus B is equal to sum. Then I can come up with values for A and B such that A and B both are even, right? So in this case, because all these numbers are even, or in this case A and B are even, so definitely they are not co-prime, because 2 definitely would be a factor of them, right? So from this I can simply state that if my L modulus 2 equal to 0, that means if my left, right, is even, then I already got the answer, because I can now say that L by 2 and L by 2 would be the 2 numbers I want. But here's the edge case. The edge case is, what if L is equal to 2? In case L is equal to 2, then I'll say, okay, 1 and 1 are the answer, because L by 2 and L by 2 would equate to 1 and 1. However, that's not correct. The simple reason being that 1 and 1 have a GCD of 1, right? Which is wrong. Cool. Now what if L is greater than 2? Right? If L is greater than 2, then I can say that, okay, this case is not gonna rise. But then there are different checks that are gonna come into picture. So this was a very fundamental idea, that if the number is even, so we can obviously play with even and odd. But what if the number which we are getting is something like L is less than R, right? in this case I can say that, okay, if L is odd, right, and I'm assuming that over here L is greater than 2, right? If L is odd, then L minus 1 can be numbers, because L is odd, then L minus 1 would be even, and L plus 1 can be one of the numbers. Since I have said over here that L is less than R, so L plus 1 would be less than equal to R, so it would definitely fall into the range, right? But now the problem would be that L minus 1 plus L plus 1 would technically be 2L, which could go out of the range, so I can just replace this by 2. So L minus 1 plus 2 would actually be L plus 1, right? And since I said L plus 1 is less than equal to R, as L is less than R, hence this would definitely satisfy, right? But the edge case becomes, what if L is equal to R, right? In this case, if L and R or both are the same number, so if L is a prime number, in that case answer cannot exist, right? Because you can't just come up with two numbers which sum up to a prime number. But if L and R are not prime, in that case there's a simple way to calculate it. So let's say your L and R was 21, right? So what I can say is, what's the factor of it, or what's the first factor of it? 3 is a factor of 21, right? So I'll say 3 into 7 is 21. I hope that is correct. Now I can break this 7 down, because this number I'm keeping as constant. So I can break this 7 down into two numbers. I can either break it down into 1 plus 6. That's very simple, like breaking down the very simple way. So this I'm getting. So I'll say 3 into 1 and 3 into 6 are the two numbers. Now obviously both of these numbers have 3 in their multiplication, so they won't be co-prime. And on top of that, I can generalize it as that if your number is not prime, then the answer is first factor, right? And the second number would be first factor, comma, the number itself, or L you can say, divided by first factor. Okay, minus 1 into first factor. Don't worry, I'll show it in the code. But yeah, that's the observation. That's how I derived it over here as well, right? Cool. So let's have a look at the code, because there are some edge cases that need to be discussed. So my code is a bit shabby. You can definitely improve it if you want. But yeah, here's my code. So firstly, okay. So I'm checking if L is equal to R, right? Then in that case, I can actually remove it and still it will make the same sense. But just to simplify it, if L is even and L is greater than 2, so just to get rid of that scenario wherein L is equal to 2 and R equal to 2, in this case answer definitely doesn't exist, right? So I'm specifically checking this. If this is the scenario, then L by 2 and L by 2 would be two numbers, because both of them are same, so they won't be co-prime, and they would sum up to L, so that would be perfectly fine. Else if it's a prime number, I do have a formula written for prime. So if it's a prime number, then minus 1 is the answer. Else I'll try to calculate the first factor. So I'm calculating the first factor over here, right? And then the second, so let's say then the first factor is f, right? So the second factor definitely would be L divided by f, correct? Now I'm saying that the first number is this L divided by f minus 1 into f, and second number is f, as discussed. Cool. Now what if R minus L is greater than or equal to 3? Now in that case, I can simply say that I want to make both the number even, right? I want two even numbers that sum up to a value which lies between L and R, right? In that case, I can say one number can be 2 and the other number can be can depend on L. So if L is odd, right, in that case I'll take L plus 1. If L is even, then I can directly take L. Now the other case is if L is greater than or equal to 2 and R minus L differ by a value 2, right? In that case, the logic will differ by would be a bit different. So I'll be saying that if L is even, well and good. Else I'll be replacing it by L minus 1. You can definitely club like maybe 3 of these if statements into one using ternary operators. But so as to simplify, I use this particular pattern. Now if L is greater than or equal to 2 and R is greater than L. Now R is greater than L basically means that the difference could be as low as just 1, right? In that case, what could happen? Now specifically over here, I'm saying that L modulus L modulus 2 is not equal to 0, right? That basically means L is odd, right? So in order to get the two even numbers, I can say 2 and L minus 1 are the two even numbers. Cool. And one another case I'm covering is if L is greater than 2 and R is greater than L, and now if L is even, right, then 2 and L minus 2 can definitely be two numbers. Else, if none of these cases are applicable, then print minus 1. I'm pretty much sure that these things can be combined into a single if statement using ternary operator. Maybe beneath this video, I'll just put a short code for this. The reason I did it this way is because I was getting trapped inside the test cases. So I just wanted to understand and elaborate a bit on it. And that's why you're saying this particular formulation. Cool. Next, let's move to the next problem, that is plus minus permutation. So I don't know why it's the dth problem. I think it's kind of easy. It's more logical, to be honest. So the problem simply states that there's a permutation that you can make, right? And you have two numbers x and y. Now whatever permutation you write, whatever numbers would be at the places which are divisible by x. For example, if your x is 2, then the factors or the multiples of 2 are 2, 4, 6, right? So this is at the second place, following one base indexing. This is at the second place, this is at the fourth place, this is at the sixth place, right? So you'll add these numbers, and whatever positions would be occupied by the numbers that are divisible by y. For example, y is 3, so its multiples over here are 3 and 6. So 1, 2, 3, that is 1, and 4, 5, 6, that is 4. It would be subtracted, and we have to maximize the value. Now a fairly simple problem, just the basic mathematics or high school mathematics is required over here. So let's quickly go through it. So basically I'll say that I want to maximize my maximize the numbers falling at position divisible by x, right, and minimize the numbers falling at position divisible by y, right? But you have to consider that there might be some places that are divisible by both x and y. So what should we do about them? To be honest, they don't matter, because at one place you will be adding it and at one place you will be subtracting it, right? So you shouldn't be concerned about those. You should only be concerned about the positions that are only divisible by x and that are only divisible by y. For y, you will have to take the minimum possible values, and for x, you have to take the maximum possible values. So your permutation technically contains all the numbers, so it would be something of this sorts. Let's say we are going all the way up to maybe like 100, so it would be like this, right? Now what I want is that for the values y, I'll be using these values, and for the values x, I'll be using these values, right? So at the end, I just need a simple AP formula to calculate the sums and subtract it. It's as easy as that. So let's have a look at the code. Sorry, I can't complicate this stuff if it's fairly easy. So anyway, yeah, this is the code for it. Pretty short. You can even make it shorter, but cool. So I firstly have to find out what is the LCM. So I'm finding the LCM. One way to find the LCM is just to multiply it and divide by the GCD. That's how I'm doing it. Now why do I need to find the LCM? Because as I said that there would be some places that are divisible by both x and y. So I need to find them, right? So let's call this LCM. I've called it common or com. So let's call this LCM. Now how many places would these be? So these would technically be n divided by com. For example, if your number of integers are 10, right, and the value that is or you can say the LCM is 4, then basically there are two places that are 4 and 8, which would be divisible by both the numbers, right? Cool. And similarly, in order to not populate another variable, I just divide placed n by x inside of x and n by y inside of y. On top of that, now I have to subtract the places that were common, right? So I'll just subtract common divisors from x and common divisors from y. After that, the sum of x would technically, let's say sum of y, because y is actually going from 1, right, so to so on, right? So the sum is fairly simple. It's n by 2 into a plus l, or n into a plus l divided by 2. So n over here would be number of terms that are y into the first term, that is 1, and the last term, that is y divided by 2, right? And the sum of x would be the number of terms that would be x The last term would be n definitely, because we are trying to go we are going till the end, so it would be like n minus 2, n minus 1, and n, right? So we are gonna consider the last x terms, right? And over here the first term would technically be minus x plus 1. For example, if my x was 2, then my last term would my first term would have been n minus 1, right? If my x was 3, so I would have considered the last three terms. In that case, the first term would have been n minus 2. So n minus x plus 1 would give me the first term, and obviously divide by 2, and at the end just print some x minus some y. That would give you the answer. Cool, let's move to the last problem. The last problem is interesting. I'm not sure why a lot of people didn't do it. It's not that tough per se. So the problem states that it kind of looks big because they have explained the example, but we'll try to go through it quickly. Cool. So the problem states that you are given an array of integers a1 up to an, as well as a binary string is consisting of n characters. And then there are two kind of operations you can perform. One LR. So what one LR basically does is that it takes your binary string and it inverts all the bits from L to R, right? And the other operation that you can do is 2G. Now what 2G does is, where G can be either 0 or 1. Now 2G basically picks up all the values. For example, let's say G over here is 0, right? So it will go to the binary string. It will see where all zeros are present, right? It will see where all zeros are present, and then it will take the values from the array where zeros are present. So for example, over here, if you say 2 0, so you say that okay, you want to perform the second operation on zeros. So it'll go to the binary string. It'll say that okay, 0 is present over here and over here, right? Corresponding to that, what are the numbers? So the corresponding to that, the numbers are 2 and 3. So it will take a XOR of it. That would be 1. You have to print that. Yeah, as simple as that. And now at the end, so what you have to do is you have to perform this operation, and whenever 2G is given to you, you have to print the bitwise XOR of the elements that I just illustrated. Now the point is how you can do it. There definitely would be a lot many approaches. I tried one of the easiest approach in my opinion. Like there could be easier approach, but that didn't come to my mind. So what I did is I used a prefix XOR sum. So that's kind of easy. So initially, so the basic idea behind it is, let me just explain the idea as well before we move on. Okay. So the basic idea is that if you XOR anything twice, right? So if I say A XOR A, that would be 0. Anything XORed twice would be 0. So rather than taking something out of the XOR, I can just XOR it again, right? So what do I mean by that? So initially I'll say that, okay, I want to populate my x0 and x1. So x0 would mean all the values that are having a value 0 in the binary string, right? And x1 would mean all the values corresponding to the positions which are set to 1 in the binary string, right? I can populate these one. These are fairly easy, right? Now, if operation 1LR comes to me, then I know that I need to invert all the bits in the binary string, right? Now, obviously, it won't have any impact right now towards me. So why do I even care about it? The simple reason is that what I'll do now is I'll initially create a prefix XOR sum, or prefix XOR array, you can say. Prefix XOR array. So from this, in an order of one operation, I can just say that, okay, prefix of R XOR prefix of L would give me the XOR of all the elements from L to R, right? Or over here, it has to be L minus 1, sorry. Yeah. So this would give me the prefix of all the elements from L to R. I'll just XOR them to my X0 and to my X1 as well. But wait, won't this cause a problem? It actually won't, because initially when you have populated x0 and x1, you have taken care, for example, let's say some element A was there in x0, right? Now what would happen is, as soon as you will XOR it with the entire range, right? So A would again get XORed and its value would become 0. However, in case of x1, where A was not present, so it would be XORed for the very first time and it would appear as A itself. So that's a very basic fundamental level clarity about XORs, right? And that's all that was required for this particular problem. And if you know this, then this problem becomes fairly simple. So over here, this is exactly what I've done. I've taken a prefix XOR. I've just called it pref, right? And I populated it. Now I started my traversal from 1 because while calculating the prefix, I have to go for -1 as well. So I didn't want to put a check over here, so I just did it right over here itself. That's basic stuff. I think you can do that. Right. After that, I calculated the prefix XOR. That's also not something that is too tough. Over here, I'm just checking that if my bit is a 0, then let's XOR this value to x0. Else let's XOR this value to x1. Right. Then for all the operations or for all the queries, initially I'm checking what type of operation it is. If it's of type 1, then ask the user for L and R, that are the limits. Now over here I am taking R minus 1 and L minus 2, but in the problem I said that we'll be taking R and L minus 1. The simple reason is that over here they have given the values in one base indexing, hence I have to subtract one more from that, right? Yeah, that's exactly what I'm doing. And also I have to check that if L is greater than 1, only in that case I need to do it, because if L is greater than equal to like if L is equal to 1, that technically means the entire array from the very beginning is being considered, right? Now if that kind of a case is arising, uh, then I just have to XOR it by 0, right? Because I have to consider the element to the left of it. Now it would be foolish to XOR it by 0, so I'm not doing anything in the L scenario. And similarly for x1, if t is equal to 2, that basically means that now you have to calculate the value of 2g at the head, as they had specified over here. Yeah, over here. So in that case, I'll just check. I'm just again taking the value in the same variable itself so as to save space. Cool. If t is equal to 1 now, like if you want to check for the 1's bit, then I'll print x1. If you want to check for the 0th bit, then I'll print x0. And yeah, that's pretty much it. I hope you understood the basic logics of how these things are being implemented. If you haven't, then I'll recommend going back to the video, try to understand it once more. Else, just comment it down. I'll definitely help you out with that. And if you want more help, you can definitely join the Discord server. I'll put the links in the comment section below. Cool guys, thanks a lot for watching this video. Bye bye.